I think it kind of craps out. Poor little dude. Okay. So the last thing I want to do is talk about a few things that we didn't hit on and what we discussed. When you do that first homework assignment, that cumulative review of chapter 1 through 6, there are going to be things that you have forgotten. So that little warm-up sheet certainly didn't have everything on it, right? So tomorrow, what's going to be really important for you is to have done this so you have questions tomorrow. So then, that's my thinking with quizzes. I never give you a quiz the day after I teach you something. It's always at least 2 days later, so you have the middle day to ask questions from the homework, right? If you're keeping up with homework. So there's one thing in particular. Let me see, what was the other thing I wanted to do? Oh yeah. Two things, and then I'll let you out. So we talked about solving equations. When you solve inequalities, there's only one thing that's really different. And real quick, I like it when I first started doing this, I put my drink right there, and then it was like an Escher thing. All right, so when you solve inequalities, and what the hell is that? What's an inequality? What's that mean? Give me an example of an inequality. Don't say, well, women only get paid 70%. No.
1 equals 2.
I agree with you, but a mathematical inequality.
1 equals 2.
Oh, no. So 1 is less than 2.
Right.
That's an inequality. Sure. That's an inequality. So inequality means anything that's not exactly equal to. It's allowed to be different. It's an inequality. Right? Is this true? This one here, is it true? Of course it is.
Yeah.
Because what's the symbol mean? 4 is greater than or equal to. Yeah. To be, or means you have to do one of these two things, right? I always call it as like the nice bouncer. You have to have a lot of money, or you have to look good, or you have to have a nice car. And I'm like, what else? Or you have to know Joe, the bar. I know Joe. That can go in. So or, it's a nice bouncer. This is true. This is equal to. But of course, we're not going to start with, statements like this. We're going to start with, x plus 3 is greater than 2x minus 7, something like that. Right? So let me kind of do this. Let me lead you guys down a path here. So if I subtract. The nice thing is, almost every step is the exact same as solving equations. You want to get all the x's on one side, all the numbers on the other side. There's only one difference, really. Subtract 3. Negative x is greater than negative 10. So here's where the difference comes into play. Because what am I going to do now to get the x by itself? Divide by negative 1.
Does that flip the sign?
Yeah. So then you have to flip the sign. Now, why? I don't know if you picked up. You're also going to have to graph this bad boy and do interval notation with this thing. But let me talk real quick about why this is true. Why the hell do you have to do that? Except for the fact that you've been told to do that.
Divided.
But why does that explain? Do you see what I'm saying? Has anybody ever shown you why you have to flip that stupid sign? Okay. But why does that make that happen? If I divide by 2, I don't have to do that. You see what I'm saying? So which one of these is bigger?
2.
2. Now divide both sides by negative 1. What does this become? What does this become?
1.
Which one's bigger?
So 1.
Holy shit, right? So when you multiply or divide by negative, you change the side of 0 you're on. So if this guy was bigger than this guy, now it's the other way around.
It's like a number line type thing.
Exactly. Yeah. So 2 and negative 1. And when I multiply by negative or divide by negative, it's going to switch. So now the relationship is opposite. Do you guys see that? So why does this work the same way? Because what's x? A number I don't know yet. And how do numbers work? That way. So why does this happen? Because that's what numbers do. I love that. Right? Maybe. So again, never accept on face value, this is how math works. And because if you just accept that, a little part of your brain goes, oh, this is shit. But I'm just going to do what makes this person happy, so I get a passing grade. And that's sad to me, because it's impossible for something to just well, let's see, let's just change the sign. Yeah, that's going to screw a lot of people. No, there's got to be some reason behind it. There's got to be a reason. And if I can't tell you why I can't do my job, I should stop and go do something else. So how do I do the rest of this? How do I graph this thing? Make a little number line. Make sure that 10 shows up. 9, 10, 11. I love the people that no matter what, they have to have 0 show up. So x is greater than 80. 0 and 80. Holy shit. We're past 88. I don't have to make sure that you know where 9 is related to 10 on the number line. What symbol do I put on the 10, though? Yeah, parentheses. So if you're used to open circle, if you're used to an open circle because it's not allowed to equal it, well, just use, part of an open circle. And in closed circle, what does a closed circle mean? It means you want to include it, right? The first letter is I, so instead of the you would use a bracket. So brackets and parentheses take the place of circles. Why? Because those are the symbols we use in interval notation. Hopefully these words are not brand new to you. It might be true. I don't know. So to do this, I'd say, which way am I going to shade? Yeah, the way that this points. If the variable's here, it's the way this points. You've got to love that shit. Right? I'm going to shade this way. So I'm going to put a parenthesis on it like this because it's going to kind of point in the direction it's shading. So if I was shading above, I would have put it this way. I like it. Maybe. So then interval notation, what's the smallest it could be? Good. Negative infinity. Up to almost 10. Right? So if it would have been, if the problem would have been if I would have worked the problem out and I would have said x is greater than or equal to -5 or something like that, right? Draw him a little number line, did -5. You can do it, Jeff. There you go, buddy. What symbol would I put on here now?
Bracket.
Bracket. Opening that way because I'm going to shade that way. Open, go that way. Interval notation, what's the smallest it could be? Good. Same symbol. Up to infinity. And you never put a bracket here because then you're saying that you can find infinity, which is the next level of philosophy. Math is a philosophy, to tell you honestly, but that would be the next. That's like Powder shit, where you get hit by the lightning. No, Powder. Never seen a movie Powder. Okay. Yeah, so don't put a bracket on there because then you're telling me that you can find it. And please, dear God, don't do this. Right? Because then I'll be like, holy shit, what's that? All right? Okay, maybe. Infinity is not a number, it is a process. It's not the largest number, it is a process. I like it. So here's the last thing. I told you 2 things. One thing was inequality. So the last thing that's going to relate to what we're going to do tomorrow. Oh, you're going to love this. Take a minute, and maybe it's been a while. So I just want you to do this. Take a minute and long divide this. You can do it, Jeff. It doesn't matter. You can do it, man. Sure. So what's the steps here? Hopefully you guys can see I just made a nice one. But it's been a while for some of us. What's the steps here? 7 goes into 49. 7. You put the answer, 7 times 7 is 49. And then you change the sign. Subtract it. Change the sign. You get 0. You bring down the 4. 7 goes into 4. No. Bring down the 2. 7 goes into 42. 6 times. And then, you bring it down, change the sign, 0. No remainder. I like it. Now, since variables are numbers that I don't know yet, I can also long divide variables. And then you're all like, did you watch Jurassic Park, Jeff? You can, but why should you? No. I don't know if you guys remember good old Jeff Goldblum. You never asked if you should. So if I had x plus 2 into x squared plus, you be there, Jeff? Yeah. 8x plus, let's see. Yeah, plus 12. Let's think it goes in even. Now watch. I want you guys to realize why it's okay to do what I'm about to do. A real quick little example. If I had 81, I'm not going to do this all the way out, into 6,722. How would you figure out what number to put? You wouldn't try to do 81 into 672. What would you actually think? You would think 8 into 67, right? In fact, you might not even realize that's what you do. So what number would I try here? 8. And then I'd do 8 times 81, not just 8 times 80, of course, right? So look, that's where people freak out over there. So I'm not gonna pay attention to 2 at first. I'm gonna go x goes into x squared. X times what is x squared? X. Okay. So what would I do with that now? I would multiply it by this, write what I got down here, and then I would change the sign. So here, multiply what I got by this. So what do I get when I multiply?
X squared.
X squared
2x.
plus 2x. And then I would change the signs. Okay. I'm doing all the same steps. It's just sometimes people don't realize they're the same steps. And then I combine. X squared minus x squared. Gone. 8x minus 2x. 6x. Bring down the plus 12. So let me know. Have you guys done this before, this long division? You should have. Should have. If you haven't, I know this is only one example we've done so far, but does it make sense so far? Maybe it's the first one you've ever seen. It's exactly the same steps. People don't believe me when I say that, but it's just because you're not used to the look. Now what do? X goes into 6x. It's positive 6 times. 6 times x is 6x. 6 times 2 is 12. Change the signs. No remainder. So now notice this. X squared plus 8x plus 12 is x plus 2 times x plus 6. That's what that means, right? Same way as I could say 4,942 is 7 times 706. So this is actually a way to factor something even. Especially if this was really gross. So what we're going to do tomorrow is we're going to improve this process. This is gross. What's the only thing that really matters? What's always going to happen to this shit that's here? It's going to cancel. So who cares about that? I want to make a process that really only cares about the 8 minus 2 and the 12 minus 12. I want a process that only takes into account what really matters. And there is a process. It's called, oh, you're going to love this shit. It's called synthetic division. Oh, that sounds yummy. Some of you guys know it. If you know it, what do you think about it? Thank you. And the rest of you are like, you paid her, didn't you? She's placed here, didn't she? No, that's awesome. Because once you learn it, you're like, screw this shit. Unfortunately, it doesn't work for everything. But what it works for, it makes the process stupid easy. Okay. So that's going to be tomorrow. So what I'm trying to imply here is we're done for today. Yeah, don't get used to it again. I'm not going to let you out at 10 every day. What time is it?